Hi, welcome to the component standard breakout meeting for discussing component config problems, issues, and solutions. This is intended as a collaborative meeting between the component standard working group and API machinery. And we would like to discuss the agenda today is in an ad hoc meeting document that's been linked in the Zoom chat as well as our Slack channel. And thanks to Ross for initially putting together this meeting. Ross, do you want to take it away?
Okay, so I'll share my screen. Can you see the doc?
Yep.
Okay, so the first question here is what is like the place where we would like component configs for different components. So the idea is that many components would like to store their configs in component maps, but we don't want to force that onto components. We would like some soft solution. Try to just have a file from the components perspective, and whether this file is actually stored into a config map and brought on as a config map volume source, or whether this is actually pulled from somewhere else and put up together by an init container or something like this. Like this is basically the choice of the deployer. So actually, we need to figure out what we should do in this case and whether we want to force a consistent policy on all of the components, or basically allow every component to go their own way.
So where we're at currently, as far as I'm aware, is that we ask components to provide a config flag that accepts a file name. This is compatible when a component is hosted in a Kubernetes cluster with the config map strategy. And then we've got some additional magic happening with other components that are not hosted by Kubernetes being able to fetch from the API. I believe just the kubelet, if I'm not mistaken. But, or is that only done with Kubernetes machinery?
Well, currently I'm aware of with kubeadm, kubeproxy, and it's kubelet, but it's done in two different ways, although both configs are actually stored in config maps. So we actually also should probably agree on the fact that component configs should be some sort of opaque objects from the perspective of the API server. So basically they're simply stored as a blob of information inside of a config map. So do we have at least partial agreement?
I don't think that it's the minimum or that it's the simplest object. I think that it should be possible to run Kubernetes outside of using Kubernetes hosting services. But you might argue that the configs should be introspectable. So we've had issues in the past with people trying to determine like what subnet a cluster is running in order to configure a networking add-on, and not being able to introspect the API server config makes it really difficult to know what that value is, like just from the primitives inside the cluster. So I guess that's like running from files outside the cluster and not having the cluster being able to know the config, like versus having the config be stored in the cluster or some middle ground between the two. like where the configs are always propagated into some place by their components, is like those are all very different ideas. I think I can agree that config maps are a sensible place to put configs.
Yeah, and they're like one of the places to put configs, not just the only place to put configs.
Yeah, it's I mean, can we answer the question of like whether configs should always be introspectable from the API?
Well,
Is that a rule?
like I think that it's like I support your opinion that we should probably not force everyone to store their configs inside the cluster, and basically allow people to just uh, inspect them with whatever tools they would like, and possibly allow cloud providers to store them whenever and wherever they like.
I guess like because if you look at other tools in the space, like Prometheus has a config endpoint, you know, where you can see what the running config is. Docker has Docker info. Containerd, you can inspect like how it's running. So I mean, it makes sense that with some level of access, you should be able to know, but you may need to query the component itself and not just the API. The API is a central place, whereas the components may not. I mean, most components have an HTTP and metrics server in Kubernetes land.
Right.
It's just, it's a weird question to ask because of how many components we have in the system.
Yeah.
Right now, is there some sort of like debug endpoint which gives that information, like what config parameters are set?
I'm not aware of like any endpoint that you can actually query, but like the unwritten rule is to allow components to get their config via ---- config option, and probably somehow query that one.
I do think that we don't have this as a written rule, but in general, config should not hold sensitive information. Like secrets should be pointed to from a config, but never contained within the config. So if nothing secret should ever be in a configuration file, then it may be reasonable to suggest that there should be an introspection endpoint. But that might get into the information disclosure portions of security attack surface. So I'm not sure. We would need to get some feedback on that.
Yeah, I agree with that.
And then as far as when an introspection endpoint would be built for every component, like that's a whole other question. I don't believe that we have those right now. The only form of introspections we have are the canonical places that we store configs in config maps. And so then you could, you know, if you had permission to read those config maps, you could ask the API server, assuming the components are sourcing from them. But yeah, that's a very informal, schemaless like place right now. Kubernetes does something interesting in that it's storing multiple versions of the kubelet config in different config maps, if I'm not mistaken. So there's even that. I think we have listed here that the component name would be the key, but version at a minimum is at least another key. And then if people are running, you know, components for different reasons, you may even need additional keys So
Yeah, I think that this is actually probably going to go away at some point in the future, simply because it gives us some headaches with regards to following up the Kubernetes queue policy close enough. I think that Lubomir actually has much more information in details with this one.
So I have a few comments about this question in general. If you want to store a component config in the cluster, in my understanding config map, my understanding here is that you use the cluster here as a medium to transfer the component config from one node to another, or this is this is a component config that applies to all the nodes. So it has to be shared basic configuration, some sort of a base configuration for all the components that run on the nodes. If you look at the kubelet, this is one of their components. But then if you want to apply customizations on top of this base component config, it starts becoming a case where the config cannot be in the cluster because it's no longer shared. It's customization per node. And I'm not going to talk about the kubelet details, but in general, it feels to me like if we want to store a component config in the cluster, in a config map, the recommendation should be that this is something that is shared and it should work on all the components that are running on different nodes. And then there has to be another, like the current work in kubeproxy, where you have a separate, the plan for kubeproxy, where you have a separate configuration object that is applied on top of the base configuration. I'm not sure if everybody has seen the proposal for kubeproxy, but I feel this is the right thing to do. I don't think we should limit the users. They should do whatever they want, but we can have some recommendations like, do you really want to version the name of a config map? My initial reaction here is that we shouldn't recommend this. It's up to the component to attempt to read this configuration. If it's old, it can try to convert it. If it's too old, it can error out, which I think should be expected instead of versioning and then the deployer managing this.
I have some questions and I think some fundamental like disagreements and understanding on problem space. So if there's only one config map allowed in the cluster, then it makes it very difficult to do a proper rolling upgrade of components if there are multiple of them. The kubelet is a great example. If like a rolling upgrade should always allow you to store both versions of the config that are intended to be used explicitly. They should never be implicitly loaded because components started at a certain time. And that does not need to even be a different version of the kubelet config API or different versions of kubelets. It can be the same version of software and configuration API with different values being rolled out across the cluster.
Yeah, and kubectl
supporting rolling update
has the append hash option to automate the naming of config maps for you. It'll add a suffix to it so that you can have the same prefix with a different suffix and then roll out the new suffix.
I'm sorry, I'm having a hard time hearing. I can't even tell who's speaking.
Oh, sorry, it's me. Mike's here now.
Hi, Mike.
Does that better? Do I just need to talk louder?
Yeah, we're getting a little better.
Okay, yeah, I don't know if something on my mic is messed up. It's just my Mac, so yeah, I don't know what it is. But yeah, so kubectl has an option called --append hash. That'll append a short hash to the end of the name of the config map you're creating. So if you're, and I think Customize even supports that or has its own implementation of the same thing. So if you are, changing the data that goes into config map, you'll get a new config map with a new name, and then you can roll that new one out by changing the reference on a deployment, or if it's like kubectconfig, that's in the node object or whatever, that's pretty streamlined to do it that way. So we're not forcing anyone to change config maps in place, even today.
So I think that we actually crashed into the second question, which is about migration of different component configs and like their versions. So here is another question, like whether we should actually allow this to be done solely by the component itself, like upgrade their own config map when a version is like changed, or like their own config when a version is changed in the config, or whether we should actually ask cluster provisioning tools to actually do that for us.
Yeah, so I think there's like actually a couple sub questions here. One is like, who's responsible for their API? Well, the component's responsible for its API, like full stop. So the component has to do something. The component owners are going to have to do some amount of work to allow those conversions to happen. Now, I think the second question is, like, it sounds like there's a common piece here on some method of upconverting and writing back out, or like querying a component for what, the data in the old version would look like in the new version, or something like that. And maybe that's something that we can reach common ground on and implement as a common tool. So I want to separate those two. The framework for like upconverting is maybe something common, but the responsibility for making sure the conversions for your component's API are correct and implemented is down to the owners of that component.
Are we sure that we intend all config files to be able to be upconverted from all versions? Version boundaries are what we would typically use to do things like stop supporting old deprecated options.
Yeah, that's right. So I think, like, if you read the API rules, correct me if I'm wrong, Jordan, but it basically says you need to support conversions between all.
That's true for RESTful APIs, because
Sure.
we simultaneously serve those and have to read and write in both directions, right? Like if I submit a V1 object, I have to be able to turn around and serve that to V1 beta 1 consumers. But
Right.
config is the direction only goes in, right? Like
maybe. I think when we start thinking about tools like kubeadm that write config out, and if kubeadm's involved or some other tools involved in an upgrade, there was a conversation a few weeks ago about whether such a tool should be able to automatically upconvert your config across a version boundary for you. And I think that's where we got
that puts kubeadm in the position of consuming component config rather than producing it, which seems strange to me.
Maybe, or, well, yes. Yeah, so I don't know what the kubeadm folks have an opinion on there, but it came up, and that's, I think, why we were talking about it.
Yeah, I think that, like, generally speaking, in most cases, we would actually be like just converting already existing options. So nothing that's really dropped out of support. So allowing us to upconvert like component configs for the components that are managed by kubeadmin will actually allow us to do like simple upgrade that's like just not bothering users to go and manually edit YAML files. So in the corner cases where actually there are present options that are actually deprecated and like being deleted, we can always just fail the upgrade and point the user to that like piece of YAML and that component config and tell them like you need to just change that config option or delete it from the component config and make sure not to use it in order to allow for an automatic upgrade of via kubeadm, or like manage of the cluster on your own.
Yeah, the other thing that typically happens on version boundaries is changes in default values. And we often use version boundaries to improve defaults. So a good example is number of retained replica sets for a deployment. In earlier versions of deployments, we would just retain like infinite numbers of replica sets. And in later versions, we said, you know what, like that should be an API field. And in newer versions of deployments, let's default to 10. Another example is on the kubelet. The default authentication and authorization mode when loading from a config file are secure, as opposed to loading from flags, which defaults to insecure. Automatic conversion would output the new config file version with equivalent behavior to the old config file version. And so if when bumping to the new version, we just slurp in the old one, apply all the old defaults, convert, and then output the new version, we are losing most of the point of the version boundary, which is defaults improved. And if you didn't express opinions in the old config, this automatic conversion would automatically make you carry along those bad defaults that we know we don't want.
I mean, we in theory have the option of changing behavior across the automatic conversion. If it's a tool doing it, the tool can just say, hey, this is how the tool works, right?
Yeah, we can. That's not something that users would expect us to do.
Right, like
maybe not.
A version boundary typically is intended to be a conscious change. Like I was writing to this old API, I could expect the behavior of that old API to be consistent release to release. When I change to the new API, what are the differences between them? And it seems like this automatic conversion is trying to hide and mask that, which either means you do something unexpected to users, which is change behavior silently, or it does what we don't want, which is lose the benefit of the version boundary. By hiding this from users, it seems like we're defeating some of the purpose of versioning.
I just want to add some helpful context to this conversation regarding, if you haven't seen the optional fields and kept from Justin SB regarding component config, this touches on the topic of conversions a little bit. Basically, it's a solvable problem to be able to know when working with the internal version of an API what fields were set and not set. And that information is not enforced to be available in API machinery right now. Since that information is not available, the only product that you can get when converting from one external version to another is all of the fields being set from the internal version. And you don't know whether or not, right, like you can remove fields that are equal to the default, but you don't know if the user actually intended for those to be set.
Even if we preserve the ability to have pointer fields internally, defaults happen on the specific version. So you would decode the old version, apply defaults, convert to internal, then convert to the new version. Like you lose.
Yes. So what I'm expressing there is in that assumption, which is that you could write a more sophisticated conversion that allows the target API's defaults to be set, but only for fields that were not previously set in the source API version.
And I think the question is not down to whether it's possible to do that more advanced conversion, but whether like, is it a good idea, and or like, what's the context where it's a bad idea and what's the context where it's actually helpful to people. And I think Jordan's point is that, look, if you just do it transparently, people aren't going to expect that, especially if you haven't warned them about it, and it's going to break stuff and they're going to freak out. So
yes,
the tool is adding a layer between the API and the user, and so in a sense, the tool is its own API, right? Like people are invoking kubeatom in a certain way with command line flags or overrides or something, and expecting consistent behavior. So like kubeatom has become its own API, even though under the covers it's making use of component config APIs.
Yeah, and that's a problem too, right? Like if kubeadm becomes its own API, well, crap, kubeadm can never like change the defaults either.
So my I do have a proposed solution that I was working toward with that kind of background, which is that you have the ability to do a sophisticated conversion that preserves what the user is explicitly intending in their file, that is exposed via the component's command line API as an explicit action that's documented as to what it's doing. The other conversion type, maybe could also be available through that method, but that when an old API is provided to a component, that we do the existing automatic conversion as noted in the document.
When you say an old API is provided, we do the automatic conversion. I mean, the point of consuming config files
to the internal version.
Yeah, that's how they work today. The kubelet, if you give it a v1 beta 1, it applies defaults, converts to internal. So yes, that's what I would expect to happen. The issue is the round tripping. Like if it's going to consume an old file and produce a new file, that's not something that components have done.
I would say in general that components should not do that, and that installers should be discouraged from doing that automatically.
I think that what the question is like today. Now, correct me if I'm wrong, because I'm not super familiar with kubeadm and I don't use it frequently. However, my impression is today kubeadm has its config for kubeadm, and as a result of that, it spits out configs for components of Kubernetes. And I think the sort of question is, across upgrades over a long period of time, we have to assume that in terms of the Kubernetes components, old versions will be eliminated. And what kubeadm was spitting out for those before, it will no longer be able to provide, and it'll have to go to the new version. And the question is how to manage that transition from the end user of kubeadm's perspective. So does kubeadm have to, be more helpful and say, hey, look, we're going to spit out new versions of these configs and defaults change. Do you want the new behavior? Or do you want to maintain your old behavior or something like that? But I think that, eventually there's going to be a version boundary where kubeadm no longer, the old version that kubeadm was using is no longer supported, and it will have to do something.
Yeah, that's precisely my point. And it's not only kubeadm problem, it's basically every other cluster provisioner out there that's supporting upgrade of some sort.
Yeah, I would have expected a tool like kubeatom to not try to convert from one config version to another, but rather to generate either config version. It's generating a config file based on some set of inputs, either its own internal defaults or the user preferences.
Even if it does that, defaults can change in the underlying target, and behavior can change without a config change from the end user's perspective. So I think managing that experience is the trick here.
Right, and a lot of the reason that we have the requirements around defaults and behaviors staying consistent is one component in isolation doesn't know how the rest of the cluster is configured, right? And so if the API server like suddenly said, you know what, every time I talk to a kubelet, it has to be secure now. Like the API server doesn't know if all the kubelets have been configured correctly, but a cluster lifecycle tool that is responsible for setting up the whole cluster can know, like, as of this version, we have correctly set up all the kubelets. And so, like, as of, just pulling numbers out of the air, like as of 1.13, all kubelets start up with a cert that's signed by the cluster CA. So as of 1.16, it's safe to flip on the option in the API server to like require that level of security. And if the insecure behavior is the kind of thing that is deprecated at a version boundary, then when if kubeatom hadn't made that shift yet, and it started writing like v1 API server config, and the API server was like, nope, you got to be secure now. Like that would be a signal to kubeatom, oh, we have to manage this transition. And once all the ducks are in a row and like it has safely phased in the config in the kubelet and safely phased in the config in the API server, then it can start writing v1 config and everyone's happy. And from the user's perspective, it's seamless because kubeatom managed wiring up all the components over a series of releases. The user doesn't care that the API server, or they might care, but they don't know that the API server flipped to being secure. They just know my cluster kept working. So that's more what I expected. Like the cluster lifecycle tool that has knowledge of the different components and knows how it is configuring them, over time moves them to stop using deprecated options, to start using more secure options. And once it's safe to move all of the pieces to work together and you're not using any more deprecated options, then you can start writing the new v1 config.
Yeah,
that disallows those old options.
That's a pretty reasonable expectation. How much does kubeadm abstract on top of the sort of low-level knobs of Kubernetes, or does it just expose a lot of low-level bits that'll change across? Like
it does expose basically everything. So almost like kubeproxy and kubelet do have their entire component configs exposed, so you can actually supply them. And in addition to that, we also support extra arcs and extra volumes for all of the Kubernetes core components. So you can actually supply an extra arc to the API server, and you can actually override practically everything that's exposed via command line. And in addition to that, kubeadm actually does have some knowledge and hardwires a bunch of stuff, and may even in some corner cases override user-supplied options.
So if the user is providing things in a versioned format, it doesn't seem like getting in the business of converting that should be kubeatom's responsibility. Like if a user is providing an alpha scheduler config, and over time that alpha config is deprecated and the beta and v1 versions become available, and like if the user has taken it on themselves to customize this install and provide like the underlying config files, then they should be responsible for updating those, being aware of the changes between them. The user doesn't have to provide those, right? Like kubeatom provides reasonable defaults if you just say, like, give me a cluster. So users who don't care don't have to worry about that, and kubeatom manages that, generates that for them. And users who do care are responsible for understanding the API they're writing.
Yeah, that's pretty much what the situation is right now. So we basically want to cover the case where users actually don't care, and we generate the like the component configs for the components. So like the most interesting case here is we have, for example, a scheduler config that's at v1 alpha 1 level, and we actually want to bump it into, for example, v1 beta 1 level. And how do we proceed with this? Do we actually, like, is kubeadm the component that stores the logic inside of it, like for bumping each and every field inside of this config, or is it actually invoking somehow either the scheduler itself or some other component to actually do that automatically, basically outsourcing the logic from kubeadm?
How is it? So it is generating a config file today, right?
Yeah.
Okay. I would expect to wait until the oldest scheduler you support also supports the new version of the config, and then just switch your generation to generate the new version of the config. I wouldn't try to read in a config and convert it and then write it back out. If you're generating the config, just generate the new version.
I think that's the simplest way to do it.
So basically regenerate the config every time upgrade.
Is that not what you're doing now?
No.
Okay.
So basically now we'll simply try to preserve it, or like if it matches kind by kind, it will actually get automatically upgraded.
Who owns the config? Does kubeadm own it, or does the administrator own it?
Well, in the case that like the user is not interested, it's probably going to be kubeadm. So if you have like initialized clustering via running kubeadm init and then kubeadm join on a bunch of machines, and you haven't supplied any config, so basically just run kubeadm init and kubeadm join, and then upgrade this version via kubeadm upgrade, you don't actually expect to be like pointed to some config map somewhere in the cluster and being told like just go and fix a bunch of fields in there.
Yeah, and like what's the behavior of kubeadm upgrade if I provide new options in new config in the kubeadm config?
It will actually try to apply them. So this is currently somewhat hacky method of allowing users to modify their cluster. So it will basically use the kubeadm upgrade logic to like propagate new config values.
It seems like we need better separation of inputs and outputs. Like if the inputs are either a fully user specified config, like at which point they're responsible for, they give us the config file, they're responsible for it. That's like the power user. I know exactly what I want, just push this out. And on the other end of the spectrum is just kubeadm install, like, I don't know what I want, give me good defaults, wire things up for me. Like those are the two ends of the spectrum. And both of those are inputs, and the output should be the config that the component consumes. And so if upgrade is like looking at the config in place and trying to do things to it, that seems like it's confusing the inputs and the outputs. It makes it so that if the user invokes kubeadm and like gives new options, it's hard to know, like, should we stomp the config that's there and like regenerate it, or should we try to like patch in these things to an existing config? Like separating inputs and outputs really, really clearly and saying the output is owned by kubeadm. The inputs are owned by the user, and the power user that fully provides a config file, like that might just be a pass-through. Like QAtom takes that and stomps it onto the output. The simplistic user that just says, give me good defaults, QAtom says, okay, I know how to build something that will work with all my other defaults, and it stomps the output. But like the inspect the thing and try to patch it in place is not going to work well, especially across version boundaries and default changes. Yeah, like you really, it makes it hard to handle cases like the thing in place is corrupted or messed up, and it's like, is it really messed up, or is this just a fancy user provided thing that we don't understand, and by fixing it we're gonna like destroy their data? And so like inputs and outputs, and QAtom owning the outputs and being free to stomp them or regenerate them or generate a peer file and roll out the new file, however the rollout happens.
Yeah, it's just much harder to reason about multi-directional data flow than going one direction. So
Yes.
I would recommend that regardless of how kubeadm does things today, we take some time to figure out how it can do things more simply, like we just talked about.
Yeah.
And that gets you away from needing to quote unquote upgrade versions of configs. So if the user provides a full config, great, they're responsible for it, pass it through. If QAtom is responsible for generating it, generate in a version that the oldest version of the component you support understands. And then, so like once v1 of a config is available, wait a few releases until the n-1 or 2 versions of the components all understand that version, and then start generating v1.
Yeah, that sounds reasonable. We'll probably investigate that one.
Yeah, why do you have to, in kubeadm's case specifically, why do you have to wait until the oldest version? Like if you're regenerating on upgrade and regenerating on downgrade, you can basically choose an arbitrary point as long as the newer version supports the newer config, right?
As long as only the specific, as long as you're not stomping config maps. If it goes into a new config map so that only the version matched components are paying attention to that, then yeah, you're right.
I think that's what we should recommend anyway, right? Because you can't, if you stop the old config map, you can't downgrade, and that's not good.
Yeah. In cases where you might need to generate configs for multiple versions of a component, like if QAtom 1.16 can deploy 1.16 or 1.15 or 1.14 kubelets, then it might be simpler to only have one copy of the generation code. Be like, well, this version of our cluster installer supports the full set of supported kubelet versions. So rather than having 2 copies of our generation code that can drift, we'll just keep generating the version that the oldest kubelet we support understands.
Yeah, that's right. That'll be easier for kubeadm to implement.
Yeah.
Yeah.
I also just want to point out that we really should be trying to name our config maps with unique identifiers so that we're not in the business of like trying to move a config to config map -old, right? So that way, like these things are just automatically, available for people to understand their downgrade story, right? And we can document that.
Yes, although the naming, if you want to generate a distinct config map, even if there's a config value change, you're not going to be able to do things like name it according to the version name, because you could have 2 successive updates that tweak an option but are still in the same version, and you'd want those configs to be
a unique identifier, as in like you can do
kubelet
component
version -hash or something.
Yeah.
Timestamp or
Yep.
something.
Yeah, kubelet, v1 alpha 1, yeah, hash, timestamp, whatever. Yeah.
And if it's unique, how are you going to permit joining nodes to be able to obtain access to this unique config map?
When you create a node object, you tell it what config map to use. And once you record that in the node API object, it gets access to read it.
Yeah, that's one option. The other, like, I don't know how kubeadm deploys. I mean, in cloud, we just put it in instance metadata and have a startup script download it.
Yeah, we have basically when kubeadm join is run, it's able to fetch the join config from the cluster. So these config maps, the active ones, can be stored there.
I see. It's a good. Like, I think the question, Jordan, too, is like, if you're not using dynamic kubelet config, how do you get it to the node?
Well, we basically download it and then restart the kubelet.
Yeah, but what does that? Does kubeadm do it?
Yeah, kubeadm does it, yeah.
It has an API client. It can, part of generating the join token can say, like, yeah, you have access to this particular config map or the config maps in the kubelet config namespace, or like.
Okay. Yeah.
Yeah.
That makes sense.
And now that you're actually specifying explicitly what configs are being used, like none of the machinery really has to change except for just that requirement, then 5 years from now, your cluster should still have the configs from today, right? Or from the next kubeadm version.
Clean up.
And you can look at your upgrade story and see that you missed
And you
defaults and all
can,
that. So.
you could add annotations or something and be like, this is for this version, or this is this timestamp or something. And then, like, once you upgrade to 116, you can clean out your 113 and earlier configs or whatever.
Yeah. Could you like do something goofy with owner references for that? And have like a parent config map that owns other ones for each version, and then when the version's gone, you just delete the parent.
I mean, as an operator, I would not be concerned with, old versions of my config maps for components sitting around in the cluster, as long as they're clearly named by their timestamp, hash, and version. I can see, like those are old API versions that were used at this timestamp with this hash. So, I mean, if you just put all three of those things in, or all four of those things into the name, like, I'm not concerned about them consuming space or anything. They give me a very clear history of how the cluster's been configured.
Yeah, I like that. That's a probably good point.
Like, there's no reason to delete that information. It's not like it's consuming a bunch of space.
Yeah.
Yeah, if the hash is content-based, especially, then if you have a process that is like reconciling config, I think a content-based hash is probably better than a timestamp, so that a reconcile process doesn't just produce an infinite series of identical config maps.
Yeah, I'm not suggesting that the timestamp be the only thing.
Yeah.
I'd suggest that you put both because they both are valuable pieces of information. One was the config used and one, or minted, and then one, like, what's the unique
You get a creation timestamp automatically, right?
Oh, yeah. There, yeah. So.
Cool. Have we you guys think we've addressed that question?
Yeah, I think we have, and there is like probably some room for the last question, which is basically exposing some sort of validation for component configs. So basically, kubeadm allows users to just do sort of basic component config validation on what it is generating. And this is probably going to go away if we move out of trees, since we can't actually use the internal types of like the different component configs. And we should probably like investigate whether we should allow for some sort of command line option or a piece of code that we can actually use inside of kubeadm to basically validate component configs, or simply like just prepare everything, like just start the kubelet and the static pods and just see if it's going up or it's crashing.
Yeah, there are like 3 levels of validation. There's kind of the direct syntax validation, like did you put a -1 in a field that should only be positive numbers or something? And then there's like referential validation. So if you reference like a TLS certain key, do those files actually exist and do they load and parse correctly? And then the third level is like environmental validation. Like if you start the kubelet on a machine without swap or with swap and you don't have the tolerate swap option turned on, like that's going to fail. And so like the first 2 can be done on other platforms, like not in the actual target environment. So as long as you like have your config directory with your main config file and the things it references, you can say like validate this bundle, and like relative file references will resolve and those things will get parsed and validated. And but the last one, like do these options make sense with my current environment? That one can really only be run in the actual target environment. But the first 2 have a lot of value.
Yeah, I think this is mostly about the first one being a more upfront error for the user.
Especially if some of the user input is folded into the config. And so it's like a user said, oh, I want this, that, and the other, and then that got generated into a config file. It'd be nice to be able to say, is this valid? Or did the user give me data that produced like an impossible config that the component's gonna barf on?
Yeah.
I mean, yeah.
Yeah, so I think it's valuable. I think the question is, how do we do it? Because there's sort of a policy that we don't export internal types from the tree. If kubeadm moves out of tree, validation code today runs on internal types. So how does it continue to consume the source of truth for validation for a given config?
There's also the question of drift. Like if validation changes, we ran into this with the kubelet. The kubelet used to run pods through API validation before it would run them. And if it was talking to a different version of the API server than it expected, the API server could give it pods, and the kubelet's copy of the API validation would actually fail on it.
And I think that's why the option of, rather than exporting code, having like a command line option on the kubelet that says just validate this config for me came up, because that kubelet version will be the target version of the kubelet, so you don't have the drift there.
I think similarly, we've considered having internal types actually be stored out of tree so that components would be able to vendor in this validation
Yeah, but that's
logic.
the case where you have drift, right? Because your kubeadm version may not have consumed the latest kubelet's validation code at the point that it's trying to deploy it.
Like you really want the version of the kubelet that you are going to run this config with to be the one that you ask, is this valid?
Yeah,
I think
so we're kind of all
a set of things that
check the binary.
Oh, sorry.
Yeah, so it sounds then that the group in general thinks execing the binary makes more sense.
I think having a consistent set of flags across components that lets you like generate a default config, validate a config, and
Consume a config would be one.
I mean, consuming is obvious. Like you have to be able to do that, but the generate and validate are useful. We need to think through like what the semantics of that are, but being able to do those three things with every component, ideally with identical flags.
Yeah, folks have asked for a help function that would generate a config for a long time.
Mm-hmm.
We already do it in Kubidium because it's such an important part of the UX.
Yeah,
I think also that conversion
scheduler.
should be in there. That's my opinion. But I think if you're going to be generating and validating configs and you're going to put the UX there, you should add conversions there. And that if users want to be converting their configs, you exec the tool. Nothing stops a tool like Kubidium from then calling those standard conversion commands from the components for the source and target versions. So.
I don't know if we want to expose conversion.
I can see reasons for and against that. I think I would wait to do that one possibly.
Just based on what we just talked about for the last half hour, like I don't want to encourage people to build on top of that yet.
Okay, so we seem to be a couple of minutes over time. Probably we should call it.
Okay.
Yeah,
this
that
is
makes
a
sense to me.
useful meeting, so thanks everyone who came.
Mm-hmm. Just a quick litmus. We have other agenda items that we did not get to. Do we want to discuss these at a later point?
Yeah, I would.
We actually got through all of them, but like the log is under the first one.
Okay, cool.
So,
well, yeah, we'll publish this. Thanks everyone for joining.
Okay. All right. Sounds good. Thank you, everyone. Have a nice day.
Bye.
Thank you.